So we're going to take from section 2.6, we're going to solve number 29. So the person who's walking, this man who's walking away from a light post and he's casting a shadow. So in part A, they're saying when he's 10 feet away from the base, what is the rate at which his shadow is moving? So there's part of thing that's hard to understand to see here is there's really two pieces to this, the rate of change of his shadow. So in the first case, we have to take the distance the man is away from the lamppost, which I know is 10, but let's just call that distance x, okay, which means the rate of change of x, dx dt, is how fast he's walking away. Specifically, in this case, he's walking away at 5 feet per second. The other piece to this, though, is his shadow. And the tip of his shadow, right, the distance between the tip of the shadow and him would be y, and then the rate that the tip of the shadow is moving would be dy dt, which is, of course, what we're trying to figure out. Okay? So in order to solve this, I need to have an equation that kind of puts these variables together. So I'm going to use similar triangles. So what I'm going to say is 15 is to x plus y as 6 is to y. Again, 6 being the height of the individual. Okay? So this is my equation. It involves both of these. So now when I take this derivative, right, I should be able to find out what dy dt is. So doing a little simplification, I'm going to get 15y equals 6 times x plus y. And actually, let's divide by 3. So 5y equals 2x plus 2y. Okay, so what do we get? Let's clean this up just a little bit more. So 3y equals 2x. So now let's go take a derivative. So I get 3 dy dt equals 2 dx dt, which means dy dt equals 2/3 times dx dt. In this case, dx dt is 5. So dy dt equals 2/3 times 5. So that equals 10/3. So dy dt equals 10/3. So let's think about what that means, because there's two questions here. One question is how fast is the tip of the shadow moving away from the lamppost, and the other question is how fast is the tip of the shadow changing. So in other words, how fast is it moving away from him? The dy dt, this specifically right here, represents how fast it is moving away from him, right? That's a change in y. So that's really answering question B. The answer to question B is it's moving away from him at a rate of 10/3. The tip of the shadow is moving away from the lamppost. In order to find that, we have to take dx dt and add it to dy dt, right? We take the rate of change of x plus the rate of change of y, and it's going to give us the rate of change of the entire shadow. So in this case, it's 5 plus 10/3, which is, what is that? 43, 15, 25/3. And that is feet per second, I think.